Hello everyone and welcome to another episode. My name is Alex, I'm a MySQL DBA. Today I want to talk about Python virtual environments. I'm gonna start with the languages overview, giving my opinion why Python is a popular language for infrastructure engineers. Then I will discuss why we need virtual environments, and then I will show how to use them for your Python projects. Coming up! Python is not the only language you'll have to deal with. In fact, the infrastructure engineers have to be versatile and at least read code in C, C++, Ruby, Go, and even Perl. You see, our job is to take different components and make them work together. MySQL is written in C, and if not right, you have to be able to read the code to investigate performance problems, find bugs, etc. Same story applies to other products. Ruby you have to know for Puppet or Chef, Go for Terraform and Orchestrator, Perl for Percona Toolkit. You have to read all of them, yet there is usually one language you write the code in. In my opinion, Python works very well as the main language to write database management software. There are several reasons for that. First of all, Python has a very low entry barrier. It took me about 2 weeks to feel confident in coding everyday tasks. It is intuitive, installed everywhere, super easy to start. At the same time, Python is very powerful. It supports object-oriented programming, which means well-designed Python applications may be very complex and not complicated. Using encapsulation, you can define a MySQL server as a class that has properties like hostname, port, role. The MySQL server class then supports some actions on it: start server, stop server, etc. Using small building blocks, you can design more complex entities like a replication cluster with its properties and methods. Python syntax allows you to write concise constructions. Think about list and dictionary comprehensions, decorators, lambda functions, etc. Next, there are a plethora of useful and high-quality libraries for Python that are available as packages on the public repository called PyPI from Python Package Index. There is a library for MySQL access, for HTTP communication, various SDKs to manage AWS, Docker, GitHub, you name it. And finally, there are a lot of tools for efficient software development. I hope you remember from my previous video that efficiency is a key for success. I'm afraid I will forget something, but here's a few examples off top of my head. PyTest and mock library for unit testing. You know, managing infrastructure, you don't do much calculations. Mostly the job of my software is to call that process, make that API call, execute that query, etc. So it's hard to overestimate the importance of a powerful mocking library. Linters like PyLint and Flake help catching subtle mistakes and ensure consistent code style. By the way, I read an opinion somewhere that strict formatting rules in Python contributed to its success. The reasoning was that a nicely written code is easier to read and maintain, which makes sense. Tools like Black help you with the code formatting. What else? Test coverage reports, especially differential coverage reports, greatly simplify code reviews. Tools like Safety check Python dependencies for security vulnerabilities. Many companies build businesses providing some help in writing software in Python. Such a powerful ecosystem doesn't happen overnight. It takes years to nourish it, and it takes tremendous effort to develop and keep modern the language itself. Okay, enough talking, let's do some Python. If you want to use Python, naturally you need to install it. Let's see what options we have here. If you develop Python application, there are at least 3 places where you run it. One is your development machine. Second is your CI/CD environment. And the third is your production environment. These can be different operating systems. So I will review 3 of them: macOS, Ubuntu, and CentOS. macOS distributes Python together with the operating system itself. If you run it, you will get Python immediately. It's version 2.7, which is not good enough because version 2 is end of life. It looks like the latest macOS also distributes Python 3. It is installed in user bin, which I believe where macOS puts Python in. Now, if you need some other version, for example, you need the latest Python 3.9, you can use Homebrew to install it. Now we have version 3.9. So now I have at least 3 Python versions on this machine. One of them comes with macOS. It's Python 2.7. One of them is Python 3, also comes with macOS. And yet another one is Python version 3.9 that I installed with Homebrew. It's installed in user local bin. How do I use these versions? So first of all, let me show you environments of each of the Python. For that, let's run Python 2 and let's see where it gets dependencies from. So if you check sys path, okay, you know what? Let's use pretty print. Okay, much better. So this Python version gets dependencies from these paths, and one of them is side packages in this directory. Okay, now let's take version 3.8. Let's import same. Okay, now you see, this version comes with Xcode. Okay, so this version gets dependencies from different environment, from different directory. All right, and if we take version 3.9, here's the environment for Python 3.9. It gets dependencies from yet another directory. So that means if I import some dependency, let's use 3.9 for now. So I have here some Python packages, and if I import something like URL lib, how to know where it's imported from? The easiest way is to run it as it is here. So we know that URL lib is imported from this Python module. So this was Python on macOS. Let's see what we've got on Ubuntu. For that we will run a container with Ubuntu Bionic. Why Bionic? It's a LTS release. It was released not so long time ago in 2018, and it's still widely used. Python obviously is not installed in a container, so let's install. let's install Python. Note, it installs Python 2.7. And now we have Python 2.7, which is again not good because Python 2 is end of life. So what about Python 3? To install it, you install package Python 3. And Ubuntu Bionic installs 3.6, which is not ideal, but it's still a good version of Python. To run it, you need to run Python 3 binary. And it's installed in user bin. What about Python? Also in user bin. So same deal with environments on Ubuntu. It's not OS specific, just directories are different. Okay, now our virtual environment, is located in here, in user local lib Python 3.7 dist packages. All right. So what about other Ubuntu versions? Let's see. Another LTS release is Ubuntu 2020, also known as Ubuntu Focal Fossa. Also, Docker image comes without Python, no surprise here. They try to keep it as small as possible. Now, if you install just Python, you will get still 2.7. And it's a release 2020. Again, to have Python 3, you need to install Python 3 package, and you will get 3.8. Not bad, not bad. What about the latest Ubuntu release? It's Ubuntu Groovy. It was released in October 2020. By default, it installs still Python 2.7. I'm not gonna install it. And Python 3 is also 3.8. Okay, no difference from Ubuntu Focal. What about CentOS? Let's see what we've got on CentOS. Okay, version 7. It installs 2.7. If you need Python 3, it installs 3.6. Okay, now let's see how we can install Python dependencies. For that, I will work on Ubuntu Bionic, and I will install two Python versions, 2.7 and 3.6. So if I want to install a dependency, there are two ways. There are more than two ways, but let's say at least more than one. One way is to install a Python package from apt repository. So, for example, let's find a popular dependency requests library. Okay, so there is a package, Python requests. That package, let's see where it installs requests. It's Python 2.7. And by the way, if you install Python requests, it will install it has a dependency on Python which is version 2.7. So when you install Python requests, it's a requests library for Python 2. Okay, so let's run Python 2 and import requests. And to find it, okay, we now see it installs dependencies in user lib. What about Python 3? Do we have it? We do. Let's import requests. It's not there. Why? because Python 3 uses a different environment. And to install requests in that environment, I will need pip3, which is not installed. So let's install it. Okay, we have pip3. It has some requirements, but requests library is not one of them. So if I want to install requests, this is how it looks like. And now if I want to import it, you see it gets requests from user locally. Effectively, we have two Python environments here. I call those system environments because they're installed by operating system package manager. This Python is mostly used by operating system itself. Usually I recommend to keep these two environments as small as possible and leave them for operating system needs itself. So I don't install any of my applications in one of the system environments. And the reason for that is because when environment gets bigger, there is a higher probability of versions conflict. So we see that Python 2 and Python 3 are available practically on every operating system. So why do we need virtual environments? Why do we need to create something more than that? And there are several reasons for that. First of all, you want same Python version and Python dependencies in your development environment, CI/CD environment, and production. Because when you develop some feature, you test it with specific version. When you run unit tests in CI/CD, the code is tested against some specific Python and dependencies versions. And you want that functionality to be preserved. You want your software to work the same way in production as well. So that's the first reason why you need same environment no matter where you run your software. Second reason is that a specific Python version you need may be not available on your operating system. We saw that on Ubuntu Bionic, the latest Python version we can get is 3.6. In some cases, it's not enough. And finally, we need virtual environments to find so-called dependencies hell problem. It happens when you run two different applications in the same environment, and both of them depend on some particular Python package, but one depends on version 4 and other depends on version 5. And the version 4 and version 5 are not compatible with each other. So that's classic example of dependency problem, of dependency conflict. The only way to handle this problem is to isolate two environments and run application A in its own environment and application B in its own environment. Let me show how I create virtual environment on my development laptop. I have some code here locally. This is a Python project, and let's say I want to do some development for this project. If you remember, I have three Python versions here: Python 2 that comes with macOS itself, Python 3.8 that comes again with macOS, and Python 3.9 that I installed with Homebrew. I will work with Python 3, and for that I need to use pip3. Let's see which version my pip3 uses. So it uses Python installed from Homebrew. That works for me, so I will go ahead with this version. To install, to create virtual environment, you need to install Python package called virtualenv. If I need to create virtual environment, it's a virtualenv command, and I need to specify Python version that I want to use for this virtual environment. Let's say I want 3.9, a directory where I want this environment to be. Now we have a directory with some files. Inside this directory we have Python. We have some dependencies. They must be in lib Python 3.9 side packages. Here we have some default dependencies. And how to use this environment. To use the environment, we need to activate it. To activate it, we need to execute this. Now, look what happens with Python path. Now when I type Python, I actually use this binary. So let's see, what version is it? It's a version 3.9. What about pip? It's also pip from virtual environment, and it has version 2101. Okay, so when I run pip list, it will show me installed Python packages in this environment. If I want to install dependencies of the backup package that I'm in right now, I need to run something like this. Okay, I have all my requirements for this software, and I also can install development version. So I can run my entry points in this environment, and look what happens. This entry point is also installed in virtual environment. So now I can run this tool. I can run tests. No, it's make test. So make test will run PyTest against this test suite with specific dependencies required by this package. And if the tests pass, I know that, okay, with this set of versions plus Python version plus the code of the tool itself, I can be sure to some degree that in production it will behave the same. Okay? virtualenv does its job, but if you work with virtual environments a lot, if you maintain several projects and you need to switch back and forth, then there is a better tool that organizes virtual environment neatly, and it's just more convenient to work with it. I'm going to remove this environment that I created with virtualenv, and I'm going to install virtualenvwrapper. So here I have virtualenv, and I want to install virtualenvwrapper. virtualenvwrapper uses virtualenv behind the scene, but also it provides some additional command line tools that you use to operate with in virtual environments. To activate those command line tools, we need to execute this virtualenvwrapper shell script. Okay. Suddenly you have work on that works. It shows you existing virtual environments. Well, I just happen to have them. I created them in past, but let's say I want to create a new one. I believe I already have virtual environment for backup. Yeah, I do. So I'm gonna remove it. I'm gonna remove it and start from scratch. So to create virtual environment. I also specify Python version 3.9, and I have to specify name of this environment. I usually name it as a directory where my software is, and it's just easier to identify virtual environment. So I create it, it's enabled automatically. So when I run with Python, it shows me that I'm in this virtual environment. And if I run the Python version, it's 3.9 as I requested. So I also can deactivate this environment, and if I want to activate it again, I just say work on backup. As simple as that. So it doesn't provide much of additional features. Practically, I use just two commands: work on to enable work environment, virtual environment, and mk virtualenv if I want to create one. So to deactivate, it's a shell script. It's a command from virtualenv package. And if I don't remember what environment I have, I just run work on, and I see that, okay, I have backup. Okay, so I can run work on backup. So virtual environment is a basic building block for your software lifecycle. You create virtual environment when you do development, when you run tests in CI/CD environment, and you create virtual environment when you package your software for production use. Doesn't matter how you package it, with Docker container or with Omnibus, as I will show later, it still runs in a virtual environment. In the next video, I will show you how to manage Python dependencies, how to specify dependencies versions, what versions you need to specify, and what's the difference between end user applications and the libraries. So stay tuned. See you later.